next is okay, you have 3 questions, okay, all in the SLB language. And you can see, all right, for the section B ni, okay, you have the register and memory address analysis, as well as the programming part. Okay, most of the time, the question will ask you about programming, 10 marks for the programming, and another 10 marks for analysis, all right? And last but not least is your section C. All right. Again, this section C comprised of 3 questions. Okay, you are required to answer 2 from 3. All right. So if you can see here, section C. Okay, the question will ask you in C programming. All the questions here are regarding your C programming, in which you are required to know the input output. All right, and then you need to know the interrupt programming, timer programming, and analog to digital programming. Okay. So without further ado, okay, hopefully we finish section A and section B, and then later in the next class or in the next online class, we'll continue with this section C here, right? Okay, so let's look at section A, question 1. I need to share this one here first. All right, can you see my Microsoft Word? Nampak tak Microsoft Word? Okay, hopefully you can see my Microsoft Word here.
Yes, we can see.
Okay, so section A, question 1A. I assume that all of you already answered this exercise that I given earlier, okay, yesterday. Okay, for the 1A, what is the answer for the 1A? Anyone can help me? The answer for 1A. Why is ROM called a non-volatile memory? I need to see the chat. All right. Okay, why? Anyone from you want to give the answers? Why is ROM called a non-volatile memory? Kenapa? Why is that? ROM is a non-volatile memory. Because, okay, there are no data loss, okay, when no power to the ROM. Okay, so data in ROM not lost when there is no power. Okay, where is my sorry. Okay, for B, what is the type of addressing mode used by the source operand in LDS instruction? Okay, which type of addressing mode for the LDS? Okay, so this one here is direct addressing mode, yeah? Direct addressing mode. Okay, next, how many input-output register are available in Atmega 32 chips? Okay, how many I/O registers? I/O registers. So how many I/O registers in Atmega 32? 64. Okay, starting from 0 to 63. Okay, total number is 64 registers. Okay, D, what I/O register is used to read signal from port A? Okay, you want to read a signal from port A. Okay, which I/O register that you're going to use? Okay, anyone can help me? Which I/O register that you're going to use? You want to read a data from port A, DDRA. No, DDRA, you cannot use the DDRA to read a signal from port A. DDRA are used to determine your port, either you want to make it as an input or output port. Okay, so this one here is pin A, right? So in order to read a signal from your port, okay, you are going to use a pin A. Okay, you recall back IO register, each of the port here, your port A, port B, port C, consists of 3 register, which is a DDRX, okay, which is to determine your input output, either you want to make it as an input port or output port, and then you should make it as an output port to send out a data from micro P to the user. You're going to use a port X register. All right, if you make your port as an input, okay, to read the data from your input device, okay, and then to bring down to your micro P, you're going to use a pin X register. Okay, E. What is the I flag value if AVR is interrupted? Okay, this one here in the, okay, if AVR is interrupted, what is the I value? Okay, your I value will be 0. Okay, every time, okay, you execute and interrupt signal service routine, what happen is I will become 0. Okay, this one already, what we call here, I already explained in my video. I'm sure I'm not share the video yet. Okay, later I will upload the video. All right, for the interrupt programming. Okay, next, what registers save its value onto the stack during subroutine call? Okay, this value here refer to your address value, okay, onto the stack during the subroutine call. Okay, where is the answer here? Okay, program counter, PC. Okay, you have a lot of registers. Okay, one of them is program counter. Okay, stack pointer is another register as well. All right, G. How many timers are available in Atmega 32? Okay, in Atmega 32, you have how many timers? Ada berapa timers in Atmega 32? Okay, you have 3 timers actually. Okay, we call it as a timer 0, timer 1, and timer 2. Right? So what is the AVR instruction for global interrupt setting? Okay. Global interrupt setting. What is that? What is the instruction for global interrupt setting? Okay, you can use the SKEE. And what is the maximum constant value used in LDI instruction? Okay, the maximum value that you can put to your register for the LDI instruction. Okay, this is the simple one. Berapa? What is the value? Okay, 255. Okay, in decimal. Ataupun you can use a hexadecimal of F. Okay, that is the maximum value that you can put by using the LDI instruction. Next, which part of Atmega 32 is dedicated for analog sensor interface? Okay, this one here you will learn in the ADC. Okay, but in the introduction of Atmega 32 pin out, you already learned about this one, yeah? Okay, what port in Atmega 32 is dedicated for ADC, analog to digital control sensor interface. What port? You have four port: port A, port B, port C, and port D. Which one use as a ADC? Okay, so this one is which port? Okay, port A. Okay, port A is dedicated for analog sensor interface. Right, so this one is for the section A. Right, next we go to section B. All right, question 2. Okay, you are required to write an assembler program that calculates the result of 1 plus 3 plus 5 plus dot 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 plus 49 plus 51. Okay, the result from this calculation is 676. Okay, in which if you sum up this number here, you will obtain the total here is 676. Okay, so in programming, you should store the result in R18 and R17. Okay, in which it says that R18 is your higher byte while R17 is for lower byte. Okay, and okay, attendance list. Okay, so that one is an attendance link. Okay, please sign your attendance. Okay, you must use loop. Okay, so you are going to use a loops. Okay, how to answer this question here? Macam mana nak buat? Right, first thing first. What are you going to do? Okay, first thing first. Okay, you need to see here. Okay, the total summation here, the total calculation from this calculation here, we produce 676. Okay, so 676, okay, means that it's greater than 255 or 8-bit data. Okay, so means that you cannot put this value here to one register. Okay, you need to use how many register here? Berapa register kena guna? 2 registers, right? You're going to use a 2 registers, okay, to save, okay, to store this summation here, okay, this result here, right? And then next, what are you going to do? Okay, based on this calculation, okay, what you get, what information that you get here from this equation here, this calculation here? Okay, what is the difference between the first number to the second number? Okay, you need to increment by 2. Okay, so the difference between first number to second number, second to third is 2. This is a difference between the two numbers. All right, and then next, what is the starting value that you're going to use? Okay, so 1 is your starting point. Okay, starting value. So how many loops that you're going to use here? Do you know how many loops that you're going to use here? 26. Oh, you already calculated that. 26. Okay, other than 26, but somehow kadang-kadang you mistakenly pick the wrong counter for the loops. What are you going to do here? Instead of using the counters, 26 counter for the loops, okay, you can compare your numbers here. Okay, so compare is x greater than 52 If yes, what happen? You exit your loop. If not, you need to keep doing this addition process. Okay. Okay. So first thing first. Okay. So now you know that. Okay, your summation here. Okay, every time you do a summation, what is okay, you will produce the R18 and R17 because this is a two register. Okay, to store your this result here 676. Okay, you need to place this value here to this register, right? And then next you need to put, okay, so this is R18 lah, so R18, R17, and then you need another register here called R20 and R19. Okay, so this R19 here, okay, will become your increment number here, okay, which is starting from first value is 3, next value is first value is 1, the next value is 3, then followed by 5, 7, 9, blah blah blah. Okay, what about R20? R20 always 0. Okay, you can put R20 0. Okay, this is how you're going to do a program. Okay, so since you have a 16-bit number, okay, what is the instruction that you're going to use here? Okay, for the lower byte, okay, this is a low byte, and this is your high byte. For the low byte, you can use the A, D, D. What about for the high byte? High byte, you can use the A, D, C. Okay, so now we start do the programming. Okay, first thing first, you need to clear this number here. Okay, because sometime, okay, if you not clear the number, maybe lah, sometime inside of this R17, R18 already has another value. So when you add with this value here, then it become wrong. Okay, so to be safe, we clear R17 and R18. Okay, so clear R17 and then followed by clear R18. So you clear this value here. Okay, the summation here R18 and R17 you clear. Okay, next, what about R19? What value that you need to put to your R19? Okay, so load your R19 with your starting number. Okay, the starting value. So this is become your R19 lah. Okay, load R19 with 1. Okay, next. After that, okay, so what about R20? So you clear again. Okay, so clear R20. And then next, any other register here that you need to use? Ada lagi tak register yang kamu nak guna? Apart from R17, 18, R90 and R20. Okay, no others register. Okay, lepas tu nak buat apa? Next, what you going to do? Right, so you increment R19. Is it correct you increment first or you add the value first? After that you increment. Because this is the first value. Okay, first. Okay, so you put 1 kat sini, this is 00, this is 00. 00 plus 1, you get the first static point. Okay, next you want to add with the second number, which is 3. Okay, how to do that? Okay, so you cannot increment R19 lagi. Okay, you cannot do this one. Okay, so what you need to do is you need to add R17 with R19. Okay, tambah dulu ya. Add R17 with R19. So sekarang ni what value of R17? R17 after you add, you will get 1 because 0 plus 1 you get 1. Okay, and then followed by ADC R18 with R20. Okay, which is R18 equal to 0 plus with 0 plus with C also 0, you get 0. So this is your first number lah. 0, 0, 0, 1, which is equal to 1. Okay, next. After that, barulah kita increment, sorry, I and C. Increment R19. How many times do you going to increment R19? Okay, 2 times. Okay, so increment R19. So what happened here? Your R19 now, this one become 2 and this one become 3. Okay. After you increment R19, what are you going to do? You need to add again lah. Betul tak? Okay, you need to add again. Okay, with to add this number again. Okay, so that's currently 1. Okay, then you have R19. What is R19? 3. So 1 plus with 3 equal to 4. Okay, so you need to plus R18, R17 with R20 with R19. So that the result will become 4. Okay, before you do the addition, which is here, kat sini, what you going to do? Okay, we need to compare. Okay, CPI. Okay, CPI R19 with 52. Okay, compare dulu. Is your R19 lebih besar daripada 52? Okay. If no, what happen? Okay. So know what instruction that you are going to use. Okay, you can use the BR. What instruction here? BR SH and BR LO. So in this case here, I use BRLO. Okay, means that if R19 smaller than 52 or equal than 52, what happen is, okay, I will ulang. So where is my ulang? I put here. Okay, so it will keep repeating until, okay, until I add here. Okay, so now what happen is, okay, for this one here, okay, so this one, so sekarang ni your R90 is 51. Okay, and then you add this value, add R70 with R19, ADC R18 with R20, and then you increment R19, increment R19, so they become 52 and 53. Okay, so I compare R90 with 52. So now what happens is, okay, the condition is not met. Okay, means that the R90 now greater than 52. What happens is, so I can put here, so it will exit the loop. So here, jump. Okay, any question? Ada soalan tak untuk question 2A? Okay, this is how you going to do, okay, to answer this question 2. Okay, first you're going to identify the information given in the question. Alright, so in this case here, you're going to use 2 register. Why 2 register? Because the summation of this calculation here are greater than 255. So you're going to need two registers, right? And then find out what is your starting value, and again, what is the difference between the first number and the second number. Find the what we call it, the difference, and then you can start with your programming. Okay, ada soalan tak? Okay, if no question, next we go to, all of you get this answer, or some of you not yet doing this exercise here. I hope all of you already tried this exercise. Okay. Okay, next. Okay, so this question here, you need to analyze the program. Okay, given the initial value of your register, you are going to analyze of this program and find out what are the destination register value after you executed each of the instruction. Alright, so complete the final result in the destination register. Okay, you're going to answer in hexadecimal value. Okay, so all the answer you're going to put here, okay, inside of this box here will be in hexadecimal number. Okay, after executing of the following instruction, these instructions are executed sequentially. All right, so this is the main important things, executed sequentially. All right, so given that the initial value of R16 is 55, R70 is 7A, R18 is 10, and R19 is A9. Okay, so the first instruction here, SEC. What is SEC do? Apa yang SEC buat? Okay, you're going to set your carry flag so that your carry flag become 1. Okay, set your carry to logic 1. Okay, next. SBCI R16 with this number. Okay, what is SBCI? Okay, subtract, okay, immediate value with a carry. Okay, so this is what the SBCI do. Okay, so what is R16? Okay, kat sini you can. Okay, so R16, what is your R16? R16 is 55. Okay, you're going to minus with, what is the value here? 0B1010111111. Okay. AF, what about your C? Carry. Okay, C is 1. Okay, you can press your calculator. 55 minus with AF minus with 1, you get? Dapat berapa kali ni? When you press the calculator, you get FFFF A5, betul tak? Okay, you will get FFFF A5. Okay, since this is only 8-bit, so we take the 8-bit data card. This one here, only this last 8 bits. Okay, so you put to your R16, so A5. What about your carry flag? What is your carry flag? So carry flag is 1. Why 1? Okay, because you see, okay, this value is smaller than this one. Betul tak? So you need to borrow. Okay, because you're going to do a subtraction, then you need to borrow from your carry flag. So that's why your carry flag become 1. Okay, next. ROL R17. Okay, so what the ROL do? Rotate through carry, rotate to the left through carry. Okay, so that is ROL. So you need to remember lah. Okay, open your instruction sets summary. Okay, and then see what the ROL do. Okay, so this is what the ROL do. Okay, so this is bit 7 and this is a bit 0. Okay, you're going to rotate to the left, okay, by 1 bit, which is it's coming from this is your C old. Go to your bit 0, while bit 7 will go to your C new. Okay, so this is your ROL. So what is the current value of R17? Berapa R17 current value? 0. Okay, 7A. 7A you convert to binary number, you get 0111 and 1010. Okay. So what is our carry here? The previous carry. What is the current carry here? Okay. Carry is 1 because we get from this the second instruction here. Okay, since your C flag is 1, so what happen is 1 from this carry will go to your bit 0. And this bit here will shift to the left by 1. So dia akan jadi 0, 1, 0. 1, 1, 1, 1. What about this 0 here? This 0 will go to your carry. Right, so this becomes 0. And this. Okay, so what is the value here? Okay, you convert this one to this binary number to your EXA, you get F5. Okay, so you write down this one is F5. Right, next CBR R19 with 8. Okay, so CBR R19 with 8. Okay, what does CBR do? Okay, anyone want to help me what the CBR do? Apa yang CBR buat? Okay, clear a certain bit in the register. Okay, so let's look at kita punya what we call here instruction set summary here. Okay, we want to see the operation for the CBR. Okay, we found out what is the CBR, mana CBR. Wait, okay, I shared. Okay. Okay, so now we see the what we call here. CBR. Where is my CBR? Clear, set. Oh, atas. CBR. Okay, so this is a CBR. Okay, CBR RDK, which is you want to clear bits in the register. Okay, so you see the operation here. All right, RD, what this dot here do? Okay, this dot here represent a logical AND. Okay, RD, the value from RD AND with FF minus with K. Okay, so we go back here. So what happened is RD you end with FF minus with K. Okay, what is your K? D is your K lah. Okay, so this one is your RD. Okay, FF minus with K. So you have FF tolak K. K is your 8. So what value you get here? Kamu akan dapat berapa di sini? F7. Alright. So RD, what is your RD? R19. A9. So A9, what is A9? 1010 1001. This is A9. And you have F7. What is your F7? 1111. And then followed by 0111. Okay, you do logical AND. What happened here? 1 end with 1, you get 1. 0 end with 1, you get 0. 0. 1 end with 0, you get 0. Okay, this one, yeah. 0 end with 1, you get 0. This is 1, 0, 1. So what is the final value here? You get A, 1. So after you execute the CBR R19 with K, you get A, 1. Okay, next, swap R17. Okay, so R17. What is the current value of R17? Okay, R17 no longer 7A, because you already have the new value, which is F5. This is the new value of your R17. Okay, when you do a swap, what happens is it will change the position. Okay, so the low neighbor will go to high neighbor, while high neighbor will go to the low neighbor. So dia akan jadi 5F. Okay, and then LDI R19 4A. So this is straightforward. Okay, this is a bonus mark actually. 4A. Just put a 4A here to your R19. Okay, actually this one also, the sweat here also another bonus mark. Okay, because you only go to your R17, see what is the current value, and then you just change the position. Okay, next, EOR. What does EOR do? Okay, EOR stand for exclusive OR. Okay, you're going to exclusive OR R18 with R19. Okay, so R18. Okay, R18, the value still not change here, so we can use this one here. So what is the value here? 0, 0, 0, 1. This is a 1, 0. And then what about R19? So R90, we take the current value of R90 is 4A. Okay, so this is 4A. 0, 1, 0, 0, 1, 1, 0. Okay, and then you do the exclusive OR. Okay, before you do a exclusive OR, you need to know the exclusive OR punya truth table lah. Okay, what is the exclusive OR truth table? Okay, A, B, F. Okay, this is the truth table here. 0, 1, 1, 0, 1, 1. Okay, 0, 0, what is the output? F. You get? When 0, 0, right? 0, 1, you get 1. 1, 0, 1, and 1, 1 is 0. Okay, so next you find out lah what is the output according to this truth table here. So you get 0, 0 is 0. This is 1, 0, 1, 1, 0, 1, 0. Okay, so the answer here is 5A. Okay, and then last but not least is NEG. Okay, what is NEG? What the NEG do? Okay, NEG is seconds complement. Okay, NEG R18. Since this is your R18, okay, so you want to negate your R18. So what you're going to do is, for the second complements, okay, so you from right to the left, okay, from bit right to the left, okay, from bit 0 to the 7, you find the first number 1. Okay, so this is your first number 1. You copy back the number here. Okay, so this one also you need to copy back the number. What about the rest after this one here? You need to do a inverting. Okay, so this one becomes 1, 0, 0, 1, 0, 1, and your R18 now have new value. What is that? A6. Okay. Any question for this question 2B? Ada soalan tak? Okay, if you okay, so if no question, then you get all the 10 marks here. Okay, next we go to question 3. Okay, so question 3, you're going to do analysis again. Okay, again another analysis. Determine the value of register R25 and carry flag after executing each fragment of two instructions below, and the fragment are independent. What is another word for independent? Means that it's not executed sequentially, right? So you need to use the original value, not the current value. Okay, the first line here, LSL R24. Okay, what the LSL do? Okay, refer back to your ni lah, instruction set summary. LSL, mana LSL? Where is our LSL? Okay, you can always refer to this instruction set summary. Okay, if you don't know what the instruction do. Okay, LSL, LSL, LSL. Right, where is my LSL? Dah lepas ke? Okay, this is LSL. Logical shift left. Okay, you see here. Okay, you see here. Dia bagi tahu kat situ. RDN. Okay, go to RDN plus 1. Means that you shift to the left by 1 bit. 0, go to your R0, RD0. While RD7, go to your C. Okay, this is how you want to read the operation here. Okay, dia bagi tahu kat situ 0 go to. Okay, so this is LSL. Okay, it says that 0 go to bit 0, while this one here, bit 7 go to your C. Okay, and then the rest will shift to the left by 1 bit. Okay, so LSL R24. What is the current value? The value of R24 is EF. So E1110, F1111. Initial C is 1. Okay, so you do the LSL. What happen is kosong. Okay, this 0 here go to your bit 0, and the rest will be shifted to the left by 1 bit. Sorry, this is 1. 1, and what about this one here? This one will go to your carry. Okay, so you put new C equal to 1. What about your new R24? What is your new R24 value? Okay, 8 plus 4 plus 3, 8 plus 4 plus 1, you get 13. 13 is equal to D lah. A, B, C, D. Okay, and then what about this one? 8 plus 4 plus 2. Okay, so this one here is 14. 14 equal to E. So you get D, E. Okay, next, ASR. Okay, again, refer to your instruction set summary. Okay, what the ASR do? Okay, for ASR stand for arithmetic shift right. Okay, so this is your arithmetic shift right. Okay, what is do? Okay, it says that RDN plus 1 go to RDN. Means that it shift to the right by 1 bit, while N is from 0 to 6 only. Okay, means that bit 7, the value no change. Okay, you copy back the bit 7, and the rest you shift to the right by 1 bit. Okay, so ataupun you can draw lah. Okay, to see it more clearly, you draw lah ASR. Okay, bit 7, you copy back your bit 7, and the rest will shift to the right by 1. Okay. And this one here, what about this bit 0 here? Bit 0 here will go to your carry flag. Okay. So the current value or ASR is A5. Okay, first A5. Okay, what is a A5? 1010. What is 50101? Okay, so the initial C is 0. Okay, so C initial value of C is 0 lah. You just put here. Okay, so what happen is first you have two instruction here. Okay, first find the first ASR, then second one find the value for the second instruction here. Okay, so first copy balik semua this one 1, and then you shift to the right by 1 bit. Okay, so dia akan jadi 1 0 1 0 1 sorry 1 0 1 0 1 0 1 0 1 0. Okay, C got 1. Okay, next you do the ASR again. Okay, so what happen is copy lagi sekali. So this one copy back and shift to the right by 1 bit. 1. This is a 1. Okay, so 1 1 0 1 0 0 1 0. So what is your C? C is 0. What about your R25? Okay, so R25, so this is 14 and this is 9, so kamu akan dapat E9. Okay, next, a combination of LSL with ROL. Okay, so then you need to find out lah what is your ROL. So ROL, what the ROL do? Okay, you refer back to your instruction set summary. ROL, dia bagi tahu kat situ rotate left through carry. Okay, you see here, bit 7 go to your carry, N go to N plus 1, C go to your 0. Okay, so this C here go to here, C all, and this one here go to your carry. C. Okay, so this is the value here. First LSL R24. Okay, what is R24? 2 3. Right, so the 2 3. Okay, so 0 0 1 0. This is 2. What about 3? 0 0 1 1. Okay, and then the initial value of your C is 1. Okay, so what happen is this carry here will go to your bit 0. Okay, and the rest will be shifted to the left by 1. So dia akan jadi 1 1 0 0 0 0 1 0. What about this 0 here? Go to your carry. Right, next. ROL R25. Okay, what is... Okay, sorry. Okay, I mix up ya, salah kat sini. Okay, the first one here is we going to use the LSL. Okay, so this is a LSL. And then after that, baru kita buat ROL. So, salah ya. So, sorry. This one is wrong. Okay, first we do the LSL. LSL. What the LSL do? 0 go to your bit 0. Okay, so it's 0. Go to your bit 0, and the rest will be shifted to the right by 1 bit. Okay, what about this 0 here? We go to your carry. Okay, this is after you did the LSS. Okay, next you are going to do the ROL R25. Okay, again you need to find out what is your R25. This is your R25. Okay, change the R25 to what we call here binary number. So kamu akan dapat 0011. This is a 3. What about C? What is a C? Okay, C is 12 ya. 110. Okay, then after that you do the ROL lah. Okay, CO. What is our current C? Is it 1 or 0? The currency. 1 atau kosong? Okay, 0. So this is the currency. Okay, so 0 will go to your bit 0. Okay, and then the rest will be shifted to the left by 1 bit. Okay, what about this 0 here? This 0 here will go to your carry flag. Okay, so what is the value that you get here? You can get, okay, so this is a 0. This is 7. 8. Okay, so 7, 8 for R25. What about R24? What is the value of R24? So this is the value of R24 lah, yang ni. Okay, this one. This is your R24. What is your R24 value? 3. Sorry, this is your R24. Okay, this is R24. This one. Okay, 46. Okay, so this is R5. This is R24. This is when after you did the ROL. Okay, next. The next instruction is LSR R24 and then ROR R25. So you need to find out what is LSR. So what the LSR do? Okay, refer to your instruction set summary. Says that for the LSR, 0 go to your bit 7, while this one go to your carry flag. From bit 0 to your carry flag. And ROR, okay, so terbalik je. From ROL, what happen is, okay, you draw here, this is a CO, go to bit 7, while this bit 0 here masuk ke new C. Okay, so R21. R24, what is the value of R24? So this is R24. R24 is 26. Okay, so again 0, 0, 1, 0, this is a 2, and then followed by 6, 0, 1, 1, 0. Okay, then what you're going to do? Do the LSR. So do the LSR, what happen is 0 go to bit 7. Okay, the rest will be shifted to the right by 1 bit. Okay, what about this one here? Akan masuk ke dalam kamu punya carry. Okay, so this is R24. What is the R24 value? You will get 1. Sorry, 1, 3. Okay, next. You're going to do ROR R25. So R25, what is the current value of R25? 5E. Okay, so 1, 0, 1, 0, 1. This is a 5. What about E? 1, 1, 1, 0. And you're going to do the ROR. Okay, CO. What is your CO? Is it, where is your CO coming from? Okay, from this one. This is your CO. Yeah? Okay, so this C here will go to your bit 0. Bit 7. And the rest will be shifted to the right by 1 bit. 1, satu. What about this one here? This one will go into your new sheet. Okay, so value, this one become 2f. Okay, so you just write down this one is 2f. What about your c? The c here, you take this one. This is your final c. 0. Okay, any question up until here? Ada soalan tak? Okay, if no question, next we are going to do the, okay, this one here. We still in question 3, question 3b. Okay, you are going to compute the following equation. It says that given an equation of y equal to x kuasa 2 plus 2x plus 5. Okay, in which x is stored in the RAM location at address hundreds. Okay, it says that at x here store dekat address 100. And the result of the equation y is saved in RAM at location 102. Okay, so y need to put, okay, you need to put your y at location 102. The result of this x here, okay, the result from this equation here must be stored to your address 102. Okay, initial assembler directive are given. Okay, you already given that this initial assembler directive. Assume that x value is in the range of 0 to 9. Means that the maximum value of x is 9, while minimum value of x is 0. Okay, how to do that? Macam mana nak buat? Okay, so first thing first, what you're going to do is you need to find out what is the maximum number that will be stored to this y here. Okay, so you replace lah. Okay, this is the minimum kosong, so this is your x lah, x between 9 and 0. Okay, so you take 9, put into this equation. Okay, 9 power of 2 multiply with 2 plus 5. What you get here? Berapa kamu dapat? 81 plus 18. Somebody please help me. 81 plus 18 tambah dengan 5 plus 14. 104. Okay, so 104 is less than 255. Okay, so means that you can use 1 byte to, or 1 register to store this number here. Okay, so why not in this case here? Okay, why not this one here, this x here, you put to your R16, and okay, and then after that you store the equation to your 102. So macam mana nak buat ni? How to write down the program? Okay, you have x kuasa 2 plus 2x plus 5. Okay, let's your x here is R16. Okay, so dia akan jadi R16 multiply with R16 plus with 2 multiply with R16 and plus with 5. How to do that in programming? Okay, anyone want to help here? How to, okay, do the programming for this equation here? Macam mana nak buat? Okay, first thing first, what are you going to do? Ada siapa nak tolong tak? Okay, first thing first, what are you going to do? Okay, first thing first, you're going to load, okay, value from this address 100 to your R16. Okay, because the value here, this value here, which is from 0 to 9, is stored in your address 100. We don't know what is the value. Okay, we just assume that the maximum value is 9. Okay, we want to make sure, we want to see whether we need to have 2 register or only 1 register. So that's why we replace this 9 here to this equation, and we found out that 1 register is enough to store this result here. Okay, so what are you going to do? Okay, so you need to load, okay, this address here, okay, the value from 100 address to your X, which is R16, by using the LDS instruction. So LDS R16 08100. Okay, so apa yang berlaku kat sini, R16 will have value from address 100. Okay, next, what are you going to do after you add these things here? Nick says that we need to load y. Why we need to load y? Because we want to store the y, which is the result of this equation here, to this address. Okay, so we are not going to load the y. Okay, the y value here. Okay, STS. Okay, you already load the value and then you're going to store. Is it? No, you need to do the equation first lah. After you do this equation, then you're going to store to your y. Okay, next, what are we going to do? This, okay, so this is the first equation that you're going to do. Okay, x power of 2. Okay, R16 multiply with R16. Okay, what instruction that you're going to use here? Instruction apa kita pakai? Okay, use the MUL. MUL R16 with R16. Okay, don't use the MULS, because MULS for the sign number. Okay, because this is, you see here, 09. This is a positive number. Okay, 0 to 9 is positive number. So you're going to use the MUL only. Okay, don't use the MULS. Jangan guna. Okay, after you do the MUL, where this the result of this multiply will be stored? Dekat mana dia akan disimpan? Why? No. Okay. After you do the MUL, the result will be stored at R1 and R0. Okay, every time you use the MUL, MULS, MULSU, okay, the result will be stored to R1, R0. Okay. Again, go to your instruction set summary. Okay, if you're not, okay, you can find out MUL. Mana kita punya MUL? Ada tak? MUL. Okay. See here. MUL multiply unsigned number RD minus with RR. Put the result to your R1, R0. Okay. Always refer to your instruction set summary. Okay, if you don't know where the result will be stored, always refer to your instruction set summary. Okay, so this instruction here, the result will be stored at R1, R0. But the question is, which register that we're going to which register that you're going to need to use in the next instruction? Is it R1 or R0? Let's say lah, just now we have 9. 9 multiply with 9, you get 81. Okay, 81 is less than 255, which is, it is only, you need require only 1 byte or 1 register. Okay, so that's why we need to use the R0. Okay. Okay, so this 81 here will be stored to R0, not R1. Okay, because it's only 8-bit data. Okay, so next, what are you going to do? Okay, you move move this one here, the hasil here, or if you don't want to move also can. Okay, so no need to move lah. Okay, so we just know that the hasil here store dekat R0. R0 sama dengan R16 darab R16. Okay, after you multiply this one here, okay, you are already finished this one here. Okay, this one is checked. What about this one? 2x. What instruction that you're going to use? 2x. Okay, we're going to use the LSL. Okay, refer back to the what we call the lecture notes. Okay, LSL, when you do the LSL means that you multiply the value from that register by 2. Okay, so we're going to use LSL. Which register that we're going to do this LSL? R16 lah, because it is X. Okay, so R16. Okay, LSL R16. So kat sini apa berlaku? So this one here you dah buat 2x. Okay, 2.x here. Okay, next. What about this one? 5. How to do this 5 here? Okay, you're going to do the add. Before you add, what are you going to do? Okay, because add, for the add you see here, mana kita punya add? Okay, add is between register and register. You cannot add an immediate data. ADD, where is my ADD? See? ADD, RD with RR only. You cannot add with immediate data. Okay, so kita load dulu. We load this number here. This number here to any register. Let's say lah, this one you use R18 lah. Okay, LDI R18 with 5, and then after that we add this number here. Okay, so ADD. Okay, first you add. Okay, hasil this one tadi. Okay, which is you store dekat R0, and this one you store dekat R16, and this one you put it at R18. So what happened here is you want to add R0 plus R16 plus R18. Okay, why not we use the ADD R0 R16? Okay, and then ADD R0 with R18. Okay, next. After that, what are we going to do? Okay, then after that, we're going to use the STS. Okay, what address that you're going to store here? The address 102. Which register? R0. Okay, so that's all for this programming here. Okay, to program the program for this equation here. Okay, any question? Sampai sini ada soalan tak? Okay, why LSL R16? Because we want to multiply by 2. Okay, if you refer back to your what we call here, mana kita punya ni tadi? Shift rotate. Okay, if you refer back to this what we call here this lecture notes, okay, module 6, you see the LSL. Alright, see here, this operation effectively multiplies signed and unsigned value by 2. See this one. Okay, if you're using the LSL, means that you multiply that number by 2. So why not, instead of using the MUL, why not we just go using the LSL here kat situ, right? So that is the explanation why we use the LSL. Okay, any other question? Okay, if no question, then we go to next question. Question 4. Okay, so this one, question 4. If you see, if you see this question 4 here, both A and B, you need to do a program. Okay, so you need to do a programming for both question for A and question for B. So in my if not mistaken, from my experience of marking question is, most of the students are answering question 2 and question 3 only. Because why? Because we have a analysis is more easier than do programming. Okay, so that's why question 4 is a least favorite question. Okay, for this what you call, for this final exam lah. And others final exam, question 4 also consist of the analysis and programming as well, both analysis and programming at the same time. Okay, so we look at the question 4A. Okay, what the question 4A one? Okay, you are required to check 100 byte of data that are stored in memory starting from address 200. Okay, so starting from address 200, okay, you already store 100 byte of data. Okay, you are going to count the number of capital letter. Okay, so inside of this address here, okay, you store the random number and random value, and now you're going to find is the, from this 100 byte, is there any capital letters found, okay, from this 100 byte here. Okay, if yes, what happen is, okay, so the data, and you need to set out how many capital letter found within this 100 byte of data. Okay, so how to know that that data consists of capital letter or not? Okay, it already given that, okay, any SKEE code, okay, that are started from 41, okay, hingga 5A, okay, is considered as a to Z. Okay, so if not mistaken lah, 41 represent capital A, while 5A here will represent capital Z. The rest will follow suit lah. Okay, 42 is capital B, 43 is capital C, etc. Okay, so now what you're going to do, you are going to write an AVR assembly language program. To do that, your program must follow the following procedure codes. Okay, given this procedure code, then you need to write down your program. Okay, so what you're going to do here is, okay, you know that this is a capital letter. Okay, the capital letter is between this number and this number here. Okay, part 1, every time you find out the 41, it means that is belong to A. Okay, every time you find out in this 100 byte of data, you find out 5A is belong to Z. So how to write a program? Okay, first set port A to be all output. Okay, macam mana nak buat ni? Okay, before we started our program here, make sure that you include, okay, this file here. Okay, include m32.inc. Okay, and then you start your program. Start your programming here, your main program. First, set port A to be all output. Why you need to set port A to be all output? Because you want to send out Okay. Okay. How many capital letter found in this 100 byte of data to your port? Okay. So that's why LDI. Okay. How to make a port A as a output? Kat mana kita nak buat? How to make a port A as an output port? Okay. You need to make sure that your DDRA get 1 or 0. You need to put 1 or 0 to your DDRA. Okay, you need to put 1 so that your port A become output. If you put 0, port A become input. Okay, so first, load IR60 OXFF and out DDRA R16. Okay, so this is a set port A to be all output. Okay, next, clear port A. Okay, how to clear port A? Okay, so you can do the CLR R16 out port A R16. So now your port A you already cleared, so that port A sama dengan kosong. So this one here, port A, you initialize your port A become output port. Okay, next, set counter to be 100. Use register R16. R16. Okay. Next, make your counter register to be 100. Okay, so load I R16 with 100. Okay, so you finish this one here, this one, and this one. And then set result to be 0. Use register R17. Okay, so you're going to use the register R17, okay, to store the result, how many capital letter that found from this 100 byte of data. Okay, so load I R17 with 0. Ataupun, or you can use the CLR R17 also correct. Okay, so R17 sama dengan kosong. This one R16 equal to 100. Okay, next. Set register X as a pointer for the data. Okay, how to do that? How to set your register X as a pointer for the data? Okay, where is your data? Okay, your first data store in your RAM. What is the memory address of your first data? 60. According to this question, okay, your data here is stored at starting what address? Definitely not 60. Okay, 200. Okay, because the static address is at 200. Okay, so this is a static address 200. So now you want to your pointer register X point to address 200. How to do that? Okay, here, set register X as a pointer for the data. Okay, your data are stored at static address of 200. Okay, now you want your pointer register X point to this address here. So what instruction that you're going to use? Macam mana nak buat? How to do that? Anyone? How to initialize so that your X point to this address 200? .org 200? No. Okay, LDR26 with 00, not LD, LDI. Okay, we can use the LDI R2600. All right, so X, how many bit of your X, pointer register X? 16 bit, correct? Or 2 byte. Okay, you have a low byte and high byte. Okay, which is consist of SL and XH ataupun R26 and R27. Okay, now you want to this X point to address 200. So this 200 here consists of 60 bit. Betul tak? Alright, so this one low and this is high. Okay, so make sure that this one XH get 02 while XL get 0, 0. Okay, so when you load this number here to your SL and XH, now you know that the X point to this address 0200. So macam mana nak buat? Load I, okay, XL with 00, ataupun you can put 0 also can, okay, di mana what happen is R26 equal to 00 and load I XH with what number here? 0x02, in which R27 okay, get 0, 2. Okay, so this is your R26 and this is R27. When you combine R27 and R26, you get your pointer register X, di mana dia akan point to what address? 0002, which is dekat address 0200 or address 200. Okay, this is how you're going to initialize your pointer register. Okay, make sure that you remember, you need to know how to initialize your pointer register. If you fail to do so, then the next instruction here will be wrong. Okay, the next instruction down here will be wrong. Okay, so this is what happened lah. Okay, X point to address 200. Okay, so we finish this one ya. Okay, lepas tu dia buat do for all 100 data. Okay, so macam mana nak buat ni? Do for all 100 data. Okay, we already initialize the counter. This is your counter, hundreds. Okay, you're going to do a loop, correct? Okay, before that, how to read the data? What instruction that you're going to use? Okay, you have the pointer register X now. How to read the data from address 200? Okay, you use the LD. Okay, we use the LD. Okay, you can pilih lah any of your register. Let's say lah this one we take R7. Okay, LD R7. The first data that you want to read here is address 200. So you put X lah. Betul tak? Okay, LD R7X means that X currently your X point to what address 200. So from address 200, you get the value from address 200, put to your R17. Okay, this is how you're going to read the data from your memory, which is starting from address 200 and put to your GPR. Okay, by using the pointer register. But in this case here, you see read next data into register R0. Okay, R0 is standard R0, so I cannot use the R7 ya. So I need to replace this one with R0. Okay, read the net data into register R0. So LD R0, X. Okay, next, what I'm going to do? Okay, I need to put plus lah. Why I need to put plus? Kenapa? Because the next data that I want to load is at what address? 201. Okay, that one I need to put the X plus here. Okay, because we want to do this to do the to do a loop okay, for this instruction. Yeah. All right, and then if it is one of capital letters, increment the result. So how to know that that one belong to capital letter? Okay, that value that you are currently load to your R0 is belong to this capital letter. How to make sure that? Macam mana nak buat? Okay, you need to compare lah. Okay, you need to compare. Alright, compare with this value here. Part 1, 41 and 5A. Okay, this is something like this lah. Okay, you already load the number. Okay, so this is your X. Okay, first you compare if your X smaller than 41. If yes, okay, then you need to load the data again. If no, what happened? You need to compare with this number, okay, 5A. If X greater than 5A, if yes, what happened? Okay, if yes, then you load again the data. If no, okay, which is X smaller than 5A, so you know that one is belong to your capital letter. So what happens is you increment your R17. Okay, because your R17 here is where you calculate how many, see how many your capital letter you found in this 100 byte of data. So increment R17. Okay, then after that you load that data until 100 data has been loaded or has been read, okay, from starting from address 200 until to, okay, you tambah lah sini. Okay, so what you going to do? Macam mana nak buat? Okay, first we need to compare lah. Can I use this one here? CPI R0, okay, with 41. Boleh tak? Can I use this one here? Can I use this instruction here? CPI R0 with 0841. Boleh ke tak? Anyone want to help me? Boleh ke tak I use that one? CPI R0 with 0841, because R0 now is my X, betul tak? This is R0. Is it R0 smaller than 41? Okay, cannot. Why? Because this is immediate data and this is your R0. So you cannot use the CPI instruction. Okay, tak guna CPI instruction. Okay, you need to use the CP. Okay, R0. Okay, but you need to load 41 to another register first. Okay, so we put kat sini ya. Okay, we load somewhere around here that value. Okay, so why not we load I R berapa lagi tak pakai? R18. Okay, R18 with value 080x41. So compare R0 with R18. Okay, we can use the BRSH or BRLO. Okay, in this case here, I use the BRSH. Okay, is it? Oh, sorry, not BRSH. So this one here, this is a BRLO. Okay, this BRSH. Okay, make sure that the branch here is correct lah. Okay, you need to use the correct one. Okay. Okay, let's say I take the BRLO. Okay, what happen when BRLO? What happen when my X here is lower than 41? Okay, when my X, okay, R0 here, lower than 41, so I need to load that data again. Okay, I need to load the data from my address, okay, address that pointed by pointer register X to my R0. Okay, so I put here load data. Okay, where I want to put this load data label? Kat mana saya nak letak? Okay, where do I need to put this label here to load the data again? Okay, so I put here load data kat situ. Okay. If my R0 smaller than 41, what happen is I load the data again. If not, okay, if my R0 is greater or equal than 41, why one? Okay, I need to compare lah. Compare with 5A. Okay, so CP compare again R0 with 5A. Again, I cannot use the CPI because this is R0. So let's this is R19. So I need to load again. Okay, so load LDI R19 with 0x5. Okay, so I compare with 5A and then okay for this one, yeah. Okay, for Y we going to use BRSH or BRLO untuk Y this condition here. If yes, which instruction that I'm going to use, BRSH or BRLO? Okay, BRSH, but and this one here is BRLO. So I use the BRSH. What happen when BRSH? What happen when Y greater than 5A? So I load the data again. If not, okay, what happen? Increase my R70. Okay, increase R70. Okay. And then after I increase R17, then I need to decrease lah. Decrease my counter R16. Okay, since my counter not equal to 0, I think that there is something wrong here. Okay, but never mind. Okay, nanti kita tengok. Alright, so this one here. So this one we cannot put the load data. We cannot put the load data because we need to decrement we need to decrement our counter first, and then after that we load that data so that we can okay so that we can read the 100 byte of data. Okay, so this one, okay, instead of you put the load data, so this one kita ganti kepada counter. Okay, this one also go to counter. Okay, where is my counter? So I need to put counter kat sini lah. Okay, so kat sini perlu tambah lagi decrement R16. Okay, after I decrement R16, if R16 still have data which is not equal to 0, so I load my data again, and it will continue until 100 times. Okay, and once my R16 equal to 0, when R16 equal to 0, okay, I need to send out lah. Okay, send out the data, okay, the result of how many capital letter I found in this 100 byte of data to my mana port A. Okay, send the result to your port A. Okay, so what happen is here is out port A R17, and kat sini you can put here jump. Okay, any question up until here? Ada soalan tak sampai sini? Okay, if no question, I think we stop here. Okay, in the next class we continue with 4B ya. Boleh tak? Okay, the next class, okay, the next live session we'll find out what is the solution for 4B as well as question 5 and question 6 and 7. Okay. Okay, for those yang tak sign attendance lagi, please do so. Okay, I give you the link once more. Okay, this is a link for the attendance. Okay, I will upload today class in the what we call here YouTube. Okay, you can find out in the YouTube. Okay, thank you class. Okay, you can dismiss.